Okay. Alright, so let's try this again. So we're going to talk about exponent rules, just the first rule, so that's why I call it rule 1. We're going to talk about what's called the product rule, and we're going to look at it through building the concept so that we can generate the rule. Now, most of the time the idea is pretty basic. I have several layered things just so we see the progression here, so we can see how the concept goes from 7th grade to kind of this basic pre-algebra concept of an algebraic connection, and then I have a couple complexity situations beyond it. But the reason why most people in algebra struggle with exponent rules, and as I've been teaching it for years, I know, the basics they take for granted. And so the concept of the basics are not completely foundationally understood. So let's just go back to them, and then we can accelerate through the problems if we understand the basics. But the challenge is that we're going to have many rules, and then we have to integrate them all into the one potential problem, and so you really need to understand them at their basic level to know why you're doing them when you have a problem that requires you to do 3 or 4 rules, and understand the flexibility that you can have within them. So first, to understand it, we have this idea of expanded form. So it's just understanding what this thing means. And here we have a base, right? So when we talk about exponents, we have kind of this format that we see, and this right here is what we call a base, and that's just basic, and then this right here is an exponent, and the base can be a number or a variable. It could be either. And then we'll talk about other things when we get to the algebraic component, but this is just some general background. So anyway, the expanded form just looks at this and says, all right, in this first situation here, I have a base of 2 with an exponent of 3, and of course, if you remember from 7th grade, exponents just mean repeated multiplication, so that 3 tells me how many times I multiply that. And then the other 4 tells me how many times I multiply the 2. Now notice that the bases are the same. That's important. It's important for the idea. If the bases aren't the same, well, then this rule won't be able to be generated, and you'll have to do other things, and of course you'll learn those over time. So let's just kind of look at this, and parentheses is just a way to group in order to sort through things, and then we look at what's in front of the parentheses, and there's nothing and just another parenthesis, which means we're multiplying the 2 groups. So because I'm just multiplying them, I can kind of drop the parentheses and just, because multiplication and parentheses mean the same thing, and just look at them from a kind of a multiplication concept. So now, since its exponents are just repeated multiplication, I take the base and now look, repeated multiplication, and so now I know I have 7 2's. Okay, well, if we kind of go back to this and I look at the exponents, I can see that 3 plus 4 is 7. So we can draw a logical conclusion that if I multiply 2 to the 3rd power times 2 to the 4th power, I end up with 7 2's. And it's important that you heard how I said that. I said to the 3rd power or to the 4th power. Some people will say cubic here. Many students will say different ways of representing it, 2 with a 3 exponent. So it's really important to hear the language, and the more you get used to thinking about it with that language, the clearer it actually will become. And so what we see here is I just kind of generated a rule that could work. Now, in order for a rule to be generated, it can't work just once. So you can't just have one trial. You have to have multiple trials, and we're going to generate it one more time here, and then we'll kind of identify the rule, and then we'll kind of look at a couple more complex examples, and this will go pretty quick. So if we just follow this logic and we say x to the 2 plus 7, we get x to the 9th. And of course, many of you are probably saying, well, I can just add 2 and 7 in my head. I don't need to write it out. But it's good just to build the concept this way so you see what's happening. And look, we've already limited the expanded form need. So again, we went straight from 7th grade to this kind of algebraic connection, which is really just a pre-algebra relationship of concepts. Now, some schools will, in the algebra class, they'll use this, but it's only to get it to kind of the next several layers. And so we're going to look at complexity level 1. And really it's just taking 2 groups and multiplying them. Again, you don't have to have parentheses, but they're there just to help formulate that this is one situation, this is another situation within the group. And math has many meanings, so this all means something, but we're looking at it abstractly today, and so that's okay. So if I want to simplify it, well, let's just think about up here. What did I do? I added the exponents, right? So let's generate a rule so that we can kind of simplify this using the same logic of the 7th grade in pre-algebra. And so our rule is going to be that if I have a to the m power times a to the n power, right? The base is a. I can just a to the m plus n power. So anytime I have two bases that are the same, and I'm multiplying them with exponents, I just add the exponents. It's very straightforward. Now, this can't be simplified because I don't know the values of m and n. So I don't say mn. So just be careful, and those are some other ideas that will be explained in other videos. But and some of you may already have that down, so it's not necessary to go do it, but just giving you a heads up. There's a lot of nuanced ideas that you kind of need to have to handle some of this mathematics. But let's look at this next. So notice that in the first group, right, we have this x. In the next group, we have this x, and it's all multiplication. So let's just group the x's together. All right. I don't want to go too much into many different years of mathematics, but this right here is just rearranging the order of multiplication. Well, you can just switch positions. If everything is just being multiplied, you can just regroup. And that's all I did, was I just grouped the x's together. And so next I'm going to group the y's together. So y to the 4th times y to the 6th. And then I have this coefficient here of the 7, but is there a coefficient over here? And there is. And there's a coefficient of a 1. And so really what I have is this 1 times 7. So you multiply coefficients. And I haven't recapped that, but at this point, coefficients should be something you are familiar with. But coefficients are just the numbers, and just the number in front of the variable. That's all it is. It's just a number in front of a variable. So like the coefficient of this x to the 2nd power, or x squared, is a 7. And it just tells me how many of the situations that I would have. And we'll talk about that in another video. I want to just keep on topic here and kind of get through how to finish this. So 1 times 7 is 7, and we don't even have to write it out. We can now just use the logic of adding the two things that are similarly grouped, right? And so I have 5 x's. I have 10 y's, and I'm done. And so now I'll give you a moment, pause before you get into this, and see if you can do it. Okay, hopefully you have paused it, and if you have not, well, then you'll get to see how to do this. And again, I'm just going to group the coefficients first, right? So I have 12 times negative 6, and then I have the r's. I have r to the 4th times r to the 7th. I have s to the 5th times s to the 8th, and I have t to the 7th times t to the 9th. And now I can just add the r's together. I have r to the 11th. Make my r look better. I can add the s's together, and I have s to the 13th. And I can add the t's together, and I get t to the 16th. Now, over here, I'm just multiplying these coefficients, which is negative 72. And so this is our simplified form of the product of those two situations. Now, I want to just add one more thing because it's probably a good idea to add it, and this is kind of another level of complexity, so we'll call it level 3 complexity. And because I've taken some things for granted that that should be known, but it's not always known. So here is some connections to other things. What if I have something like this? X, y, z times, we'll say x, y, z squared times x to the 3rd, y to the 2nd, z. Okay, so this looks awkward because I don't know what the exponent is for x. I don't know what the exponent is for y. I don't know what the exponent is for the z on this one, but I do know the z here. So can I add them together? If I knew what the exponent was here, I could add those exponents together. So how can we conclude what this exponent is? Well, it's very logical. And the example I'm going to use is if I have the number 2, well, 2 is just 2. So the exponent of 2 must be 1. So 2 to the 1st power is itself, right? So I can put a 1 exponent in every single situation that doesn't have an exponent. And that's a skill that you need to kind of incorporate, that you can understand that. And so now it's x and x. So I don't have to go back and group every single time. Once I get this idea, I can say x, 1 plus 3, I have 4 x's. 1 plus 2, I have 3 y's. 2 plus 1, I have 3 z's, and I have simplified the problem. And one last complexity level that can lead many students right into difficulty is that when we are kind of looking at this problem, we can end up with coefficient issues too. So I'll talk more about it in the next video. I just don't want this one to be too long.